Hi everyone, my name's Sam Bilbo and I am a second year PhD student at the University of Sussex in the UK, interested in creative audio coding, digital music instrument making and augmented reality technologies. Today I'm going to be presenting on my graduate student Consortium paper titled Developing Multisensory Augmented Reality as a Medium for Computational Artists. So I'm going to start this presentation with some context for the existence of my project. So multisensory human-computer interaction has been gaining lots of traction in the last 10 years. This is the interaction with computers, interfaces, and algorithmic systems via multiple human senses. And this is occurring due to lots of new explorations of novel sensory technologies and applications. Another area of human-computer interaction that's growing rapidly is augmented reality. An augmented reality system, or AR system, is widely accepted as a system that utilizes the combination of real and virtual processes, is interactive in real time, and is registered in 3 dimensions. AR has seen a recent surge in development, not only through the release of new head-mounted displays, but also through the introduction of mobile AR frameworks. This surge has resulted in its use in disciplines from neuroscience to the arts. In my research, I argue that because augmented reality is a nascent technology, being developed only in the last 20 or 30 years, it's relatively underexplored in terms of being approached through these multiple and non-visual senses. Indeed, a systematic review from 2018 found that 90% of AR usability studies conducted between 2005 and 2014 augmented just the visual sense. And so, although Azuma's definition does not rule out non-visual AR, I believe that in order to develop AR as a platform for multisensory human-computer interaction, AR needs to be thought of in a different way. So in a similar vein to Lindemann and Noma's classification of multisensory AR in 2007, Chevalier and Kiefer argue that AR must be seen as inseparable from a multisensory ecosystem that is inhabited by modes of perceptual mediation and computational relationships between sensing and mediation, human participants, and their environment. They define AR as real-time computationally mediated perception. So I believe that to develop multisensory AR requires an approach similar to that of digital music instrument making, in so doing creating multisensory augmented reality art, and thinking that I've created my practice-based compositional method to explore the following questions. What impact do multisensory AR experiences have on human perception and expression in the context of computational art? How can multisensory AR and its materiality be understood as a medium for computational artists? And how can multisensory AR in collective experiences be exploited to create new aesthetic experiences for both artists and audiences? So the methodology that I'll use to address my research questions and create a toolset for digital media and computational artists involves a bottom-up composition approach to creating multisensory augmented reality experiences, or MSAR experiences. The methodology has its roots in artistic practice and human-computer interaction design research methods, and it results in platforms for research, data collection, and of theoretical discussion, as well as media for creative use by artists. I developed this method after creating Area, a hypothesis study that explored how we can better understand the relationships between virtual and real environments through gesture and virtually placed AR sound objects. I'm going to play a short clip that I made documenting the system. The spatial audio that you can hear was being transmitted to me via head-tracking bone conduction headphones, which was the low-cost, non-visual audio AR interface that I developed. So in this clip, I'm gesturally recording, manipulating and spatializing audio samples in 3 dimensions. And this is a documentation of me experiencing it. I had bone conduction headphones on at the time. and this documentation is an after-the-fact representation, so I've overlaid the B format ambisonic sound field in the same way that it was at the time of recording. So after developing this study, I decided that the hardware designs involved should be a mix of off-the-shelf, custom-made, and open-source solutions involving inexpensive tracking input and sensory output devices. The software should be developed in a variety of cross-platform, free-to-use and high-level creative software environments, such as Unity 3D, Pure Data, Open Frameworks, and processing. So the method starts with the ideation of a multisensory AR experience, or MSAR experience. This is a possible human-to-sense interaction that leverages the relational effect between real and virtual environments as a result of real-time computational mediation. And for this step, I draw on Schappenberger's taxonomy of real and virtual relationship types and the emergent AR subforms. Once the idea satisfies the following points, I categorize each experience as either a snippet, scene, or space, depending on the computational power necessary, the sensory intensity, and desired aesthetic and form. Snippets are small clip-like experiences that occur in an interaction space equivalent to the space between a user's hands, providing up to 2 sensory experiences that are non-complex and reactive. Scenes are medium-scale experiences that occur in the space on or around the body, and they can be formed from multiple snippets or created from scratch. They ideally feature more complex sensory interactions and are interactive rather than just reactive. Spaces describe large-scale, room-sized experiences involving multiple users and potentially different zones of interaction, providing fully multisensory immersive experiences, making use of combinations of different sensory modalities as well as AR subforms and behavioral relationships between real and virtual environments. And so from MSAR experiences come the MSAR instrument and environment. So the multisensory AR instrument consists of the input, so tracking, sensors and controllers, and the output through sensory displays and actuators. So the devices needed to deliver the multisensory AR experiences. Snippets make use of a single MSAR instrument, whereas scenes and spaces use multiple instruments. As the instrument will affect the perception of the experience, their aesthetic, tangible, and material qualities are also considered in the design process. And I've categorized them into wearable, tangible, and situated instruments. So wearable instruments include forms that are worn on the body, including output via head-mounted visual, audio, olfactory, gustatory feedback devices or displays, and body-mounted proprioceptive feedback devices. A great example of a low-cost headset is Leap Motion's Project North Star, as the designs are 3D printable and open source. So this allows anyone to design add-ons, which is my current goal, to provide spatial AR audio via non-obtrusive bone conduction headphones. It also means that the headset is cheap to make compared to many others, only $500 compared to about $2,500 for most AR headsets. Gloves and wrist-mounted devices also constitute great options for input and sensory output to create multisensory AR experiences. So tangible instruments include forms that can be explored by holding or touching, such as devices that use conductive fabrics and textiles to track input, and then providing sensory feedback. They can be any object that can be grasped instrumentality by a device that can track and provide contextually aware sensory feedback via another device. So for example, a wooden cube could be transformed into a tangible instrument through real-time image recognition, and specific interactions with it could provide auditory feedback, which would probably be delivered via another wearable instrument that was processing the real-time image recognition, such as a headset with bone conduction headphones. Situated instruments include forms that are anchored in real-world environment and therefore provide location-specific experiences. And then activation might be gauged by how a user is interacting with it. So an example of a situated instrument could be an interactive projection mapping with wave field synthesis providing auditory feedback and anchored scent emitters providing olfactory feedback. So the MSAR environment consists of the software, so the runtime environments, the libraries and the engines that enable the experience. And in the case of larger spaces and more complex scenes that use spatial tracking, the setting, not only the real setting, but also the virtual setting, as it will affect the perception of the experience too. So therefore, as with the tangible design of the instrument, consideration of the aesthetic and form of both real and virtual environment is made. So the first method of study is employing autobiographical design, or ABD, research methods, as part of the process when making these experiences, as well as the instruments and environments. So the design of the ABD method so far is based around this cyclical pattern about note-taking, formalization of notes, categorization of notes, and then making changes and restarting the cycle. I'm aiming to start designing individual and group studies soon, so examining the use of small, medium-scale experiences. And the participants of these studies will be a mix of online participants. So, for example, the North Star online community for the headset has about 2,000 people in it currently, but I'm also looking at in-person experience as well. Ideally, I'm looking to perform a group study as well, revolving around an exhibition or a large-scale installation in which a multisensory AR experience space is experienced by multiple participants. And the purpose of these studies will be to iterate on designs and foster discussion about multisensory AR art, design, and interaction. So for a bit of a timeline about the project, I'm currently in the second year of my PhD study. I've started building the open source AR headset that I've been talking about, and I'm planning on developing AR experiences. So during 2021, I'd like to complete my individual studies, start planning the exhibition and group study, and my final year will be reserved for data analysis and thesis write-up. So I'd like to thank hosting this presentation to my supervisors and also to the Leverhulme Trust who fund my research at the University of Sussex.